In this demo, we will show you two examples how reverse engineering the code of Trickbot help us to develop SPL detection using Splunk's attack range. In the screen shared now, we loaded the Trickbot unpack code that was carved out from the memory in the Ghidra reverse engineering tool. We will not go deep on each of the code, but we will only focus on the interesting string that we can see in defined string view. Here, we can see that the string was cross-referenced or used in some of the function of Trickbot code. So by decrypting or decoding the string might help us to figure out what is the actual behavior of Trickbot. So we decided to extract those strings, place it in a text file, as well as the decoding key used by the Trickbot, and a Python script where we simulated the decoding function, which is a base64 algorithm with a customized base64 index table. By running this script, we can see right away several notable strings, especially the different public IP lookup service domain. These domains are used by Trickbot to recon on the compromised host to gather network information like IP addresses as part of its execution. This behavior is really unique and suspicious that can distinguish Trickbot infection, and later we will show you how we use those strings as a detection. The next one is the Trickbot share64 DLL.dll module. As you can see in this EW, that it has several functions that it may execute during the infection. But we will just focus on the function named as drop.exe in network share. This function tries to build a string in stock that are pertaining to dropping a copy of Trickbot's malware to a network share using copy file W API. So you can see it will try to drop in C share and also in admin share. Since Trickbot is C2 driven malware, sometimes during analysis, we may not be able to grab or see all the Trickbot modules in a affected machine. Or maybe the payload is different, like Cobalt Strike. But by reversing this code, we can simulate it using a simple batch script that we can see here. That will drop a executable in network share. So by running this simple batch script, we were able to simulate that one even we didn't manage or we didn't execute the actual module. Now we will show you how we use this information in detection development. For simplicity, we already loaded the data sets we have during Trickbot testing in this search head. First, we use one of the IP services domain we decoded during our analysis. And in this event, we noticed that the where manager process is trying to do a query in one of the domain we saw in our analysis. And this where manager, the TXC, is a process spawned by the actual Trickbot malware to inject its code and do its malicious behavior. So by compiling all those IP domains, we were able to detect the actual behavior of this Trickbot connecting on those IP lookup services domain. The next one is how we detect the share64.dll behavior or lateral movement by dropping copy or executable in a share folder. So we can see here, we use event code 5145 with an access mask of 002, which is write access in any of the share name listed in this search. And by running it, we were able to see that we catch the simulated sReceive.exe that we ran previously.